This video is in continuation with my previous video on vectors part 4 that you can watch if necessary by pressing the I button at the top right corner of your screen. In this video we will discuss how we can use ideas of vectors in geometry. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. In triangle ABC, D is midpoint of side BC. We have to prove that AB bar plus AC bar is equal to 2AD bar. From figure we have in triangle ABD by triangle law AB bar plus BD bar equals AD bar. Name this one. In triangle ADC again by triangle law AC bar plus CD bar equals AD bar. Name this two. Now by adding 1 and 2 we get AB bar plus BD bar plus AC bar plus CD bar equals 2AD bar. That will be AB bar plus AC bar, and this BD bar and CD bar are negative vectors of each other. Their sum will be 0, which equals 2AD bar. This is what we have to prove. In triangle ABC, AD is perpendicular BC, DE is perpendicular AC, and CF is perpendicular AC. Here these perpendiculars are known as altitudes. We have to show that these altitudes are concurrent. That is, they pass through the same point, say H. Altitudes AD and CF cut in point H. So, prove that altitudes are concurrent. It is enough to prove that vector HP bar perpendicular to AC bar. For convenience, we will choose point H to be origin O. And now HA is perpendicular BC means OA bar perpendicular BC bar. OA bar dot BC bar, that is dot product of OA bar and BC bar is 0 because they are perpendicular vectors. OA bar is A bar dot BC bar will be C bar minus B bar equals 0 vector, which is A bar dot C bar minus A bar dot B bar equals 0 vector. Name this one. Similarly, we write HC perpendicular AB, that is OC bar perpendicular AB bar. Therefore, OC bar dot AB bar will be a 0 vector because they are perpendicular vectors. This will be C bar dot, for AB bar we write B bar minus A bar equals 0 vector, which will be C bar dot B bar minus C bar dot A bar equals 0 vector. We name this 2. Now by adding 1 and 2 we get C bar dot B bar minus A bar dot B bar, because A bar dot C bar minus C bar dot A bar will be 0, and this equals 0 vector. This will be B bar dot C bar minus A bar equals 0 vector. B bar dot C bar minus A bar is AC bar equals 0 vector. Now B bar is OB bar dot AC bar equals 0, but O is H, so HB bar dot AC bar is 0 vector, and when the dot product is 0, HB bar is perpendicular, AC bar is proved. Hence, we can say that altitudes of a triangle are concurrent. In triangle ABC, perpendicular bisectors of side BC, side AC, and side AB pass through a single point, say origin O. So let us prove that perpendicular bisectors of the sides of a triangle are concurrent, which means they pass through a single point, this O. Suppose perpendicular bisectors of sides BC and AC cut each other in origin O. Therefore, it is enough to prove vector OF bar, whose position vector is F bar, is perpendicular to side AB bar, whose position vector will be B bar minus A bar. Now, OD bar perpendicular BC bar gives us OD bar dot BC bar equals 0 vector, that is d bar dot c bar minus b bar is 0 vector. But since d is midpoint of BC, d bar will be b bar plus c bar upon 2 into c bar minus b bar equals 0 vector, which is c bar plus b bar dot c bar minus b bar equals 0 vector. That will be c bar square minus b bar square equals 0 vector. That is c square minus b square equals 0, because c bar square is dot product of c bar dot c bar, which is nothing but a scalar c square. Similarly, b bar square is also b bar dot b bar self dot product, which is b square. That is c square equals b square. We name this 1. Also we have OE bar perpendicular AC bar. Therefore OE bar dot AC bar 0 vector. E bar dot C bar minus A bar equals 0 vector. E is midpoint of side AC. Therefore its position vector E bar will be C bar plus A bar upon 2 dot C bar minus A bar equals 0 vector. C bar plus A bar dot C bar minus A bar again is 0 vector. C bar square equals A bar square gives C square equals A square. Let us name this 2. Now from this 1 and this 2 we get b square equals a square, that is b square minus a square equals 0, which is b plus a into b minus a equals 0. That will be b bar plus a bar upon 2 dot b bar minus a bar equals 0 vector. But b bar plus a bar upon 2 is f bar, position vector of midpoint f, into b bar minus a bar is ab bar equals 0 vector. F bar is OF bar dot AB bar equals 0 vector. This should be b square. That proves perpendicular bisectors of sides of a triangle are concurrent. Prove that the angle subtended on this semicircle is a right angle. AB is diameter, C is center of circle, P is any point on this semicircle. We have to prove that angle APB is right angle. Let AC bar be A bar. Obviously, PC bar will be minus A bar because their magnitude is same, which is the radius of the circle, but their directions are exactly opposite. Let CP bar be radius vector R bar. Now in triangle ACP, by triangle law, AC bar plus CP bar equals AP bar. So AP bar will be AC bar is A bar plus CP bar is R bar. We name this 1. Next, in triangle CPB, by triangle law, BC bar plus CP bar equals BP bar. So BP bar will be minus A bar plus R bar. We name this 2. Now AP bar dot BP bar will be R bar plus A bar dot R bar minus A bar, which is R bar dot R bar minus R bar dot A bar plus A bar dot R bar minus A bar dot A bar, which is A bar dot R bar minus R bar dot A bar will be 0. This is R bar square minus A bar square. R bar square is self dot product, which is a scalar R square, minus A bar square is a self dot product, which is a scalar A square, which is 0 because mod R bar magnitude of R bar equals mod A bar magnitude of A bar. So we get AP bar dot BP bar equals a 0 vector. That proves AP bar perpendicular BP bar. Therefore angle APB is a right angle is proved. Viewers, if you like this video, please click the like button. Share this video with your friends and classmates. Subscribe to this channel. Post your constructive comments to make the videos better. See you in the next video. Until then, keep watching Number Collage. Thank you. This video is in continuation with my previous video on vectors. My previous video on vectors part 4 that you can watch if necessary by pressing the I button at the top right corner of your screen. In this video we will discuss how we can use ideas of vectors in geometry.